Hello, and welcome to this presentation, Getting Started with EVS1000 Marker Beacon Mode. In this presentation, we'll show you how to make measurements of marker beacons using Rohde and Schwarz EVS1000 series analyzers. This presentation assumes a basic familiarity with marker beacon signals and Rohde and Schwarz EVS1000 series analyzers. If you're unfamiliar with either of these topics, or if you'd like a review, you might want to watch the presentation Understanding ILS and/or Getting Started with the EVS1000 General Overview before continuing with this presentation. Marker beacon analysis is enabled by software option K3 and provides information on levels and modulation parameters of outer, middle, and inner marker beacons. These measurements include various modulation depth measurements, audio frequency analysis, and ID signal parameters. Measurement data can also be recorded for viewing on the EVS or for external analysis. To access marker beacon analysis mode on the EVSg1000, simply press the Mode hard key on the front of the instrument and select ILS MB. If operating the EVS over VNC, press M, and then use the down arrow to scroll through the list of available analysis modes. The first step in marker beacon analysis is entering the beacon frequency. Most marker beacons operate at a frequency of 75 MHz. To change the frequency on the EVSg, press the Channel Frequency hard key. In VNC mode, use the keyboard shortcut Q to enter the beacon frequency. Marker beacon measurements are divided into three different views on the EVS. These are Main, ID Analysis, and Recording. We'll start by looking at the Main Analysis view. The main marker beacon analysis view is divided into three sections: the level and frequency display, which provides information on the power and frequency of the received signal; the IF spectrum view, which shows power as a function of frequency; and the main numerical results, which can be figured to show various measurements and parameters of the received signal. As mentioned a moment ago, the level and frequency display shows the power and frequency of the input signal, with power shown as an absolute value in dBm and frequency shown as an offset in Hertz from the nominal or configured marker beacon frequency. The bar graph shows the overload state. Green means no overload, yellow means an approaching overload, and red indicates that an overload is occurring. If an overload condition does occur, different messages will appear depending on the type of overload. For example, here both RF and ADC overloads. Regardless of the cause of the overload, the solution is to reduce or attenuate the input level, and this can be done by setting RF attenuation to either normal or low distortion. Please see the EVS1000 General Overview presentation for more details on configuring RF attenuation. The IF spectrum preview provides a plot of power versus frequency, similar to a spectrum analyzer display. The center of the display, or the zero frequency, is the nominal beacon frequency, and the frequency range, or span, is set to the measured bandwidth. The EVS chooses a power range that will display both the peak and the noise simultaneously. The main application of the IF spectrum preview is verifying that measurement settings are appropriate. For example, we can use the IF spectrum to see if a beacon signal is present, or if there's noise or other types of interference in addition to the beacon signal. Although the EVS automatically chooses the frequency range or span based on the nav-aid type, RF spectrum mode can be used to choose a larger span if needed. This is covered in a separate presentation. Note that if RF spectrum mode is chosen, the current settings, such as the channel frequency, are transferred to that mode. The marker beacon main numerical results view shows the frequency and AM modulation depth for each of the three types of beacons. For the outer beacon, parameters for the 400 Hz low tone are shown. For the middle marker beacon, the parameters for the alternating 1300 Hz tone are given. And for the inner marker beacon, the parameters are given for the high 3000 Hz tone. The marker beacon ID analysis view displays the on-off timing parameters of the beacon signal. That is, the length and timing of the dots, dashes, and gaps that are used for each type of marker beacon. For outer markers, this is simply a repeating pattern of 400 Hz dashes. For the middle marker, which consists of alternating 1300 Hz dots and dashes, the length of both the dots and the dashes, as well as the gap between them, is shown. And for the inner marker, the duration and gap between the 3000 Hz dots is shown. The last view we'll look at is the recording view, which displays and stores marker beacon measurement data in tabular format. If GPS data is available, this data is also stored with the beacon measurement data. Data is stored with so-called status flags, which can be used to indicate various events. Please see the separate presentation, Getting Started with the EVS1000 Data Recording, for more details and step-by-step instructions on logging and exporting measured data. In this presentation, we've covered marker beacon analysis mode, which is enabled by software option K3. This option performs a wide range of measurements on marker beacon signals, including the beacon frequency, modulation depth, and the timing of the dots and/or dashes used for each type of marker. Additional displays of the received signal level and frequency, as well as a spectrum view, can be used to verify the presence of the marker beacon signal and/or the presence of other signals or noise. All measurement data can be logged together with GPS time and position information. And finally, configuration of marker beacon analysis is very easy. Simply enter the marker frequency. This concludes our presentation, Getting Started with the EVS1000 Marker Beacon Mode. If you'd like to learn more about the EVS1000 or other avionics-related topics, please see the links in the video description. Thanks for watching.